Hi, I'm an old guy and I do maths, and today we're looking into how we understand the graph of a differential. What can it tell us and what doesn't it tell us, which is equally important. Okay, so here we have a simple quadratic x squared plus 7x plus 12. This is what it looks like on a Cartesian plane. Y-intercept is at 12. The x-intercepts are at -3 and -4. How you find those is by factorizing this. Now, so this is the function of x. F dash x, f prime, is 2x plus 7. Okay, well, let's have a look at that. What does that look like? Well, we have a y-intercept at 7, and this is a linear equation with a gradient of 2, which means that this point here is 7 over 2. We can find that by making this equal 0, or by the time you've done enough of these, you realize that if the gradient is 2 and this point is 7, this will be 7 divided by 2. If it were 7 and the gradient were 1, the x-intercept over here would be -7. But that, by the way, is -7 over 2. The other important point is that this has got a y value of 0. Now, what exactly does this tell us? Well, the first thing to understand is that this is a graph of the gradient of this thing. And when you see them lined up like this, it's easy to avoid a common mistake, which is that if you give this to somebody and you say, what does the graph of the original function look like, approximately, they are likely to, well, it's possible that they could do all sorts of funny things. A common one I see is that they transfer this y-intercept to here, and that's not how this works. This doesn't tell us what the y-intercept is. Even if we integrated this, even if we went through the process of an antidifferential, what we would get is 2x squared on 2 for that, plus 7x plus c. If we had no other points of reference other than this is what we come up with, and we'd have x squared plus 7x plus c if we tidy that up. Now, it's possible, I hope you can see, that we could have a number here that is other than 12 and still have 7 here. So we can't discern from just looking at this or looking at its equation exactly what this is unless we know something more about this, such as points through which it passed or something like that. So what does this tell us? Well, as I said, it's a graph of the gradient. And the important point is here, where this thing hits the x-axis. This is the point at which the gradient of this is 0. It is that point there. And that is halfway between -3 and -4, which is -7 on 2. So that tells us that. It tells us two other things. When x is greater than this number, the gradient is positive. There we are, positive gradient from that point, the gradient of this function is positive. And below this on the x-axis, from -7 on 2 back towards a negative infinity, the gradient is negative, as you can see here. That's the important information to take away from this. Unless you have more than you might be given with that and that, it's fairly dangerous to go trying to completely reconstruct a graph. What you can do is you can make an approximate guess at what the thing might look like. Just to give you an example, if we take x plus 1 all squared, which is x squared plus 2x plus 1, and we differentiate that, we get 2x plus 2. Now, it's entirely possible. So this is f prime, and that's function of x there. Again, looking at this, it's entirely possible that we could reconstruct it, but again, we're taking a guess at what would be out here. Just let me give you a quick example. X squared plus 2x minus, let me think, minus 35. Okay, now that factorizes as x plus 7, x minus 5. Now, what's the differential of this? Well, it's 2x plus 2. And that's the danger. That's what I wanted to point out. The fact is that unless we know something about these points here, or we have some point of reference on the original graph, we're looking around kind of in the dark. However, what we would know from this is we'd find ourselves a turning point. We'd know when the gradient of the graph turned negative or positive. All useful information, but we would not know exactly what the original graph looked like. We'd know what form it would take. It would be a parabola. Okay, thank you very much for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.